this assessment, we're asked to calculate the formal charge on each of the indicated elements. Our equation for formal charge is the number of valence electrons that the element wants in its neutral ground state configuration, minus half of the bonding electrons and all of the non-bonding electrons. The non-bonding electrons are the lone pairs of electrons. When I calculate formal charge, I like to use a mnemonic that's a little bit simpler for me to remember. I like to use the equation that the formal charge is equal to wants minus owns. What does that mean? Wants is the number of valence electrons the element wants to have in its neutral ground state configuration, and owns is all of the electrons that it actually owns in this particular molecule, half the bonding and all of the non-bonding electrons. Let's use that formula for these elements here. For oxygen, oxygen wants 6 electrons in its neutral ground state configuration. In this molecule, it owns half of the bonding electrons. There's one bond between the carbon and the oxygen. It owns half of those bonding electrons. That one bond contains 2 electrons. It also owns all of the non-bonded electrons. There are 3 lone pairs on that oxygen. So for this oxygen, it owns all 6 of those non-bonding electrons. That means the formal charge for oxygen, 6 minus half of 2, is -1. We can indicate that in the structure by drawing a negative charge on that oxygen atom. For bromine, we use the same formula. Bromine wants 7 electrons in its neutral ground state configuration. It's not forming any bonds, so it doesn't have any bonding electrons to own, but it does own all of the non-bonding electrons. There are 3 lone pairs, which means there are 6 non-bonding electrons on bromine. 7 minus 6 means that this bromine has a positive 1 charge. Again, we can indicate that with a positive charge on the element. This is how we would calculate the formal charge for these 2 atoms.